Good, so Jupiter, the bully of the solar system. And let's go to another very nice feature. Well, Jupiter and his moons, we will later come back to the moons, of course. Jupiter and the moons were very dangerous for Galileo, because Galileo has seen these moons, and back then moons were only allowed to go for the Earth because everything had to circle around the Earth. But now if you say some moon is circling around another planet, yeah, obviously that back then the Catholic Church didn't really like such statements. Well, and then another feature that Galileo has seen was basically these rings of Saturn. So, strange thing, you have a sphere and then you have a ring around. If we take a closer look, well, Hubble Space Telescope, of course. The ultra UV bit, or towards the UV range, with the standard visible range, and towards the, or in the infrared range. What do we see in these rings? They are not continuously, that looks already here, as there would be basically an accumulation of many rings. Well, where do they come from? Yeah, this is now a good question. Well, we know already that disks and the angular momentum conservation play a crucial role in this formation processes. When you have local instability, everything collapses, and then there might be some rotation at the beginning. Means in the plane perpendicular to this rotation, or the rotational axis, we have this angular momentum conservation. Of course, not only in this plane, also above, but then the stuff can migrate into this plane without problem, or into a bit easier towards the center. So one chance it's just debris that is left over when Saturn has formed, or the second one, if we look at Saturn, so the rings, then we find a lot of different moons that are relatively small, even compared to our moon. For the size of the Earth, our moon is a monster. So here maybe Titan, right? Or let's say Titan, obviously the name says it already, Titan is something big. But the other moons of Saturn are not that big. Nevertheless, it's the idea that there was one too close to Saturn, and then again you have these tidal forces, and with time it's ripped apart. So what exactly it is, we're gonna see. But obviously the rings themselves also go a bit further out. It's just far less dense, and therefore almost not visible from the Earth. The rings themselves, well, thanks to this Cassini mission that flew basically through the rings and investigated what are they made of. That's mostly ice, with a few rocky components. The size of the stuff that builds the rings is a few micrometers up to a couple of meters. So basically a lot of debris. That is basically like my backyard. I have also a big pile of rubble. Here it's just nicely orbiting around the planet. Okay. So this is obviously something that makes Saturn, at least seen from Earth, special. Yet, when Voyager 1 approached Neptune, it made of course one of the major things to do was making pictures of Neptune. But then it turned out Neptune also has rings, just as Saturn. Not as obvious, but at least, oh. And this was already seen before. Well, obviously before you come to Neptune, your journey between the planets were nicely steered. We have seen the slingshot tactics to be used. And then obviously steered from one planet to the next planet. Then behind Saturn comes then Uranus, before you go to Neptune. And now, this year must be very likely, universe, blah blah blah, lunar planetary lab, whatever, I think. Okay, HST, and whatever, wide field, camera, whatever, picture of Uranus. And what do we see? Again, rings. But now, there is something very interesting. Well, the rings are perpendicular towards the rotational axis. But here, they are perpendicular towards the orbital plane that Uranus has around the Sun. So somehow, the axis Uranus is rotating is very, very twisted. We know that the Earth has this, I think, 24 degrees roughly of twist of the intrinsic rotational axis towards the revolution axis. While here it's almost 90 degrees. Oh. So the rings are not really unique to Saturn. Of course, they are more emphasized. Here they are relatively weak, and of course these planets are so far away. We need powerful telescopes, especially since they do not shine by themselves. Except of course black body radiation, but this is in the far infrared. So if we want to do optical, all we get is the reflected light, the sunlight that is reflected. And the further away, the less sunlight is there originally, and then the reflected light has to travel, and becomes very, very faint. Nevertheless, if it looks again, also Uranus has quite an amount of moons, but they are all relatively small. Small ones is usually bodies that at some point were trapped in the gravitational field of this planet. By the way, here I think Puck, Desdemona, that sounds to be Juliet. So obviously the people who have named them like Shakespeare. But the interesting thing is, here is basically the axis or the plane which Uranus is revolving around the Sun or orbiting around the Sun, and then it's 90 degree twisted almost. Well, if you take this rotation to revolution angles, it's quite interesting. The inner ones, they don't seem to be too much. The Earth is quite twisted. Mars is simply also twisted. Jupiter almost not. But it's very likely because Jupiter is the bully who did twist the others. And then we see Saturn is twisted, Uranus is massively twisted, and Neptune is twisted. And here with Uranus, that might be a consequence when basically Neptune drifted past it. So it basically disrupted the system so much that Uranus got so much twisted. So seemingly Neptune was the inner one, but at some point drifted outwards. So far so good, but there seems to be not really some bigger systematics that this is now nicely evolving as a function of the distance. So there might be also one of the major effects is very likely also the intake of mass during the formation and therefore the angular momentum. So every time a mass comes on the outside, it gives there a push, and this might provide another component to this angular momentum that is already present. But then we have a vector sum and everything is oriented a bit differently. Now if you look at these arrows, and then we look always from what we would now call the North Pole, because we are trained that North is on top, but this is, of course, there is not really an axis. What is top, what is bottom, this is just the way we have been trained. We could have easily defined the entire stuff the other way around. But if we look then from what we would now define as geographical North Pole on the planet, so Earth would be here, and then look how the planet rotates. It's quite interesting. 7 of these 8 rotate counterclockwise. But then there is Venus. Venus rotates the complete opposite direction. So whether this comes from so here this would be basically some kind of explanation that goes clockwise, because now when you rotate, in general rightwise around the sun, so this direction, and then you rotate underneath. That on the inside you might collect a bit more material than on the outside, and then of course you get this sense of orientation. But what it is with Venus? Why is Venus so special? Well, so all others rotate the other way. Possibly there was some gravitational interaction between the young Venus with the already more massive planets. So there, of course, Jupiter, that also twisted it around. Interestingly, of course, is that the revolution of all the planets is going nicely in this plane. That's what we would expect from the very beginning. You remember back this model that we have the cloud that is contracting towards gravitational collapse, and it has already some sense of rotation. Well, globally it's rotating, and then we get this accretion disk around in which then the planets form. And thanks to angular momentum conservation, we form this disk, so angular momentum is basically responsible that we find all the planets in this plane, except our dwarf planets. They are occasionally a bit inclined, what means they are twisted towards this plane. It's like here, this comet that is now in. Well, comets, these are these dirty snowballs coming either from the Kuiper or from further out, from Oort's cloud. So again, we have here our plane. And then if we go around, or very far outside the solar system, we are surrounded by this order, this massive amount of bodies. And even if there is a big distance between them, given enough time, occasionally they hit, and one of them might be hurled in the center, or towards the center, towards the sun. And then comes, of course, along as comet. So, and in the 80s, when I was a kid, there was this Giotto Comets mission, a satellite basically sent to Halley's Comet. This must have been 1986, I think. And collected there in the coma, or from the coma, particles, and it turned out it's dust and ice, a dirty snowball. And they are born that here stuff collides and then one part is hurled towards the sun. So, well, Oort's cloud, where does it come from? One idea is that Jupiter made a lot of slingshots with all the smaller bodies that came along in his way and hurled it all out, or hurled a lot out. Or the Sun certainly had siblings, so that they might have exchanged material. So then the Oort's cloud is not just one random isotropic, it also has a bit this structure. If in the very inner, we have our inner solar system, and then we have here also a bit of a plane. So, well, interestingly, if you look at Pluto's orbit, it's twisted towards this plane of the planets. So, well, of course, when the comets are randomly coming in, there's always a risk of a collision, but the risk is then again so low. And we are very lucky, because they usually come from the outside. What they see is mostly the big mass of Saturn and Jupiter often. They attract them, of course. So basically they work a bit as vacuumer to protect us from comets coming from the outer parts of the solar system. So they are a bit of a shield for us. And what happens if the Jupiter attracts one of these, so they hoover basically the danger away from us. This was about 20 years ago, 25 years ago. A comet came too close to Jupiter. Jupiter ripped it apart. And then one had all this debris impacting on Jupiter. And what you see then in this video is basically these pieces of debris, one after the other, impacting on the surface of Jupiter. And these light flashes, these are a couple of hundreds of Hiroshima bombs, each of them. So quite violent, and fortunately it was Jupiter and not us. And Jupiter is basically, we have to say thank you for hoovering most of these dangerous comets away. So at this position I would recommend you stop this video and basically enjoy this the impacts of Schumacher-Levy. This was obviously discovered by these two guys. One was Shoemaker and the other was Levi. So. Okay, and then tune in later when you have a bit recreated for the last video of this. So it should be then another 20 minutes. See you then. Bye.